Let's look at using Metasploit to compromise a computer. Now, currently I'm on my desktop, so I'm going to connect to my lab, and I have a shortcut here on the Quick Start section of my taskbar. So use the same username and password that you used for the port scanning exercise. So now I'm connected. We're going to use different IP numbers this time, and I'll send you those in an email. So I'm going to open up Remote Desktop here, and we'll start one of those. So one of the computers that we can use is 192.168.7.101. And I trust this connection. I haven't connected to it with this particular computer yet. Let me do something here real quick. For some reason, using this laptop, it doesn't automatically come up and give me full screen. So if you go to Options and under Display, if you move this over to the right where it says full screen, it should connect full screen. Now here we want to use the username administrator, and the password is capital P ASS123. And again, I'll send that to you in an email. And I've got an external mouse. There it is. It wasn't working there for a minute. I think I need a piece of paper for it to slide on. So now, through Remote Desktop, I'm connected to 192.168.7.101. What we're going to do here is we're going to use this real machine to run a virtual machine. The virtual machine is the machine we're going to compromise, and it's particularly handy to use a virtual machine for that purpose for a number of reasons, including the fact that we can take a snapshot of the state of the virtual machine before we start, and then after we compromise it, we can revert to a previous snapshot. In essence, we can roll the machine back to a known state, and we can compromise it again, even with a different exploit if we wish. So to do this, I'm going to double click here on VMware Workstation. It's on the desktop, and you can read the tips if you wish. Now I'm going to go on and power this on. I've left it suspended, and that's where I want you to leave it. It just simply cuts down on the amount of time it would have taken to get up and running. You don't have to boot it up. So you click on this little green arrow here, and it comes out of its suspended state. So now I've got my virtual machine up and running. Now, just to show you what we've got here, I'm going to go to VMware and Settings. And that's interesting. For some reason, this one's reverted back to bridged. I'll have to check that. What I wanted to use is NAT. I click OK here. Now, the reason I wanted to use NAT for the network here is this will put the virtual machine behind a virtual NAT server that's implemented by the VMware software itself. Gets us around a couple of problems, but it also proves that you can exploit a machine on a different subnet, because once you click NAT for the networking preference for your virtual machine, it's going to be put on a different network. And I'm pretty sure I had this set up properly a while ago. I'm not sure why it reverted. Let's try something here and see if it works. Now I could, at this point on the virtual machine, open up a command prompt and discover the IP number. And that's kind of cheating in this particular case, because in the real world you won't see the machine you're attacking, much less be able to sit down at it. So I'm going to try not to do that. We'll see how this plays out. I know it works, what I'm going to show you, but I'm a little bit concerned that this particular one had reverted back to NAT for the networking. And the reason I'm concerned about that is if you're using NAT, you can set the virtual machine to use or to obtain its IP number using DHCP. VMware implements a virtual DHCP server. So therefore the machine can get an IP number without you having to statically configure it. Now I will point out that in the real world, typically your servers do not obtain their IP numbers from DHCP. But in this lab situation here, either I would have to go in and statically configure it myself, or I can let the virtual DHCP server that's implemented by VMware do it for me, and I decided that was the simplest way of doing it. And in case I haven't pointed this out to you already, there are things that we do in the lab that are somewhat unusual due to the fact that it is a lab environment, and I will always try to point these things out to you as best I can, but you need to think about why things are the way they are and how that would relate to the real world. So I'm going to resist the tug here, the pull of typing in IP config and seeing what the real IP number is. And let me show you what we're going to do. Now here, you have to keep up with this. Now here I'm back on the host operating system, and I'm going to open up a command prompt here. Now these are command prompts on two different machines. Here I'm going to type in IP config /all because I need to know the virtual networks. When you install VMware Workstation, you get a couple of virtual network adapters, or VMware network adapters, and here's one of them. And notice the IP address here is 192.168.17.1, and this is for the VMware network adapter VMnet 8. There's another one, VMnet 1 here, and it's using 192.168.178.1. Well, I'm going to do a scan on first this one. If I don't find anything, I'm going to go to this one. So I need to remember this. I need to jot this down. I have a pencil here. Yeah, I think there's one right there. If I can find a piece of paper. Okay, now, so here's what I've just done here would be the equivalent in the real world of doing your fingerprinting, when you discover the IP range of interest. So now what I'm going to do, and this again is on the host operating system, I'm going to open up all programs, and somewhere in your list here you should find Nmap, and more specifically Nmap with the ZenMap GUI. Now, we haven't really used this yet. This is a port scanner. I think I had you read some documentation off of the Nmap site. So if you look at this here, that might look a bit familiar to you. This is some of the things that you saw on the Nmap site. This just has a GUI front end. So here I'm going to type 192.168, and I'm going to scan the 192.168.17.0 network first, and I'm going to scan 1 through 254. No sense scanning 255 because that's the broadcast address. Come over here and click on scan. Notice this has got set up for the intense scan. So this takes a little while. In a few minutes, if all goes well, we'll actually do a packet capture on this, and you'll see how many packets are actually blasted out here. And unfortunately, I don't think we got anything. Okay. Well, hopefully this won't confuse you too much. I'm going to go back over to my virtual machine, and I know what's happened. I need to switch this over to using DHCP. I guess I could have checked that a while ago. Now this is a Windows 2000 server, although I've got it marked unknown server, because again, in the real world at this point you really wouldn't know what it was, what operating system it was running. So I'm going to go into here to local area connection properties, and I'm just going to switch this over to obtain an IP address automatically. And from our previous exercise, it was set statically. So I'll click both of those to automatic. And of course, this is going to now utilize the virtual DHCP server that's implemented by VMware. So I'm going to resist again the temptation to check and see what its IP number is. Now we can come back over here to ZenMap and run it again. So we'll hit scan again. And sorry for the confusion there. I think what happened is probably I took a snapshot of it and I had it configured. I've tried several different ways of doing this in preparation for this lab, and then I reverted to a previous snapshot and wiped out all my changes. Now this is what I was expecting to see a while ago. We do our scan here, and Nmap starts out doing basically a ping sweep. So you see all these machines here are reported as down. However, if we scroll on down here, we find that we did get a response from 192.168.17.129. So if I'm an attacker, I make note of this IP number, and you should too, by the way. You're going to need that here in a moment, so write this number down. Now let's look at what else we've discovered here. Port 3389 is apparently open. Our TCP port 3389, that's remote desktop. That's interesting. This here is really interesting. TCP port 135. That's very interesting. TCP 53, yeah, that's DNS. TCP 25 is the Simple Mail Transfer Protocol. TCP 21 is FTP. TCP 139 and 440 is, well, 139 is Microsoft networking. 80 is the web service. I was trying to think, can't remember exactly. 443 is either secure web services or 445 is. Something just happened. It was completing a scan while I was talking here. So we get back down here where we were. Anyway, you can look through this list here and see that there's several open ports reported on this machine. Again, it's continuing the scan for services here. That's why it keeps flipping back to the top. There's more and more things being added to the bottom here. But from our standpoint here, this right here is interesting. Port, there it goes again. So you've got a lot more. I think it may be finished now. There's a lot more information down here at the bottom that's been added. We'll look at some of that here in a moment. So let's get back up here. There's a header that it found. That's interesting. Let's see. TCP. Well, look what all it's done here for us. It continued to run while I was talking. Port 21 TCP. It's running Microsoft FTP version 5. TCP port 25 is running Microsoft ESMTP 5.0 2172.1. Interesting. Apparently Winds is been installed on this particular box. So is DNS. There's a web server version IIS version 5 here, and this is the that's actually the default IIS web page there if you haven't done anything to it, which is interesting to me because if nobody's done anything to the web server, it means it's probably still open. Well, we've already discerned that it's open, but it might not be patched. So if you look on down here again, my main point of interest here at this particular time is this TCP port 135, and this is used for the Microsoft Windows RPC service, Remote Procedure Call. Now, there are exploits. Well, there are vulnerabilities in this particular service, and there are exploits that have been developed for this vulnerability. So the next thing we're going to do, let's first review what we've done so far. We've discovered the IP range of the network that we're targeting, and we used that in right up here in Nmap to do a port scan. And we discovered that there's one machine that's up alive, 192.168.17.129, and Nmap gives us just a wealth of information here about ports that are open on this machine. Now remember, an open port is an indication that there's some service or application that's listening for input from the network, and any service or application is software. Any software can have problems in the way that the application is actually written, and it's oftentimes related to what we call buffer overflows. Certain links of storage of certain lengths, blocks of storage of certain lengths, I guess would be a better way of putting it, are set aside on the stack. And if the program doesn't check for the length of an input from the network, it's oftentimes possible to send more information than the program was written to accept, and oftentimes the program will happily accept the larger block of input and stick it into the space that's set aside for a smaller input, and therefore it overwrites other critical information, including the address of the next instruction to be executed when the program returns from the subroutine that just accepted the input. So through this mechanism, it's possible to basically feed a new program to the computer and have the computer actually execute the code that we send in through the input versus what the programmer expected to be executed. So from an attacker standpoint, that's why I'm interested in these open ports. And in this case, I'm particularly interested in this TCP port 135, the Microsoft Remote Procedure Call service. So I know there's an exploit for that. I know there's a vulnerability in this service, and if it hasn't been patched, I can get an exploit and they'll use it to compromise the machine. So let's do that. Go back to the host operating system, go to all programs. Now this time we're going to find something here called Metasploit, and we're going to use the Metasploit web. There's 2 or 3 different ways you can run this. There's a console and there's Metasploit web. I haven't tried the Ruby shell. This is Metasploit's been rewritten in a programming language called Ruby, and I haven't played with this yet, but the web works okay. Although I'm going to click on that. Although it'll tell you here in a few moments that the web interface is no longer going to be supported. See this message up here at the top, but that's all right for our purposes. Now, while this is loading, let me tell you what Metasploit does. Metasploit is called a framework, and it's basically a launching platform. Metasploit has a number of exploits, and to get to these you click right here. This little button here says exploits, and this will allow you to search. Apparently this we're up to 481 different exploits. So I'm going to type in DCOM because let's pretend I did a little research here and found out that's what it's usually referred to. I could have probably found this just as well if I typed RPC. So this narrowed it down to 3 for me. So I'm going to click on the Microsoft RPC DCOM interface overflow. Now, I was telling you what Metasploit does for you. Metasploit is an attack framework. It's like a launching platform, and since it is a kind of standardized platform, people can write things for it. This particular exploit here was produced by HDM, which was HD Moore, and I can't remember who Spoon M is, and Kaz. So this was produced, this particular exploit was produced specifically to work inside of Metasploit. Now, you don't have to have Metasploit to run an exploit against a vulnerable machine or application. Metasploit simply makes it much, much easier. And you're going to see here in a moment it's so easy as to be scary. So I've picked out my exploit, and notice here it says select a target to continue. This same exploit works on all these. So I'm going to click on that, so we get another different window here. Now we have selected our exploit Now we need to select the payload that's going to be included with the exploit code that's sent across the network to this vulnerable machine that we've identified. Well, at this point we don't know if it's vulnerable or not, and if it had been patched, if it has been patched, it's not going to be vulnerable to this particular exploit. It could be there could be another vulnerability that hadn't been patched yet, but in this case we don't know for sure yet. Of course, you could probably sit there and say you wouldn't be going to all this trouble if you didn't know this was going to work, and you would be correct. So we've selected our exploit. We can also select a payload to be included with that exploit. Now there's a pretty good sized list here, and most of these I haven't played with because it seems like I never do get time. I know for a fact that this one up here at the top, or near the top, works. Windows add user. Now see what this does. Creates a new user on the computer that we are compromising, and also adds them to the local administrators group. That's interesting, isn't it? So that's what I'm going to click on. Now we're going to get another window. There are some things we have to specify here, and one of these is the target, the IP number that we are attacking, where to send the code, the exploit code. So this is 192.168. In my case here it's 17.129. It'll be different in your case. Notice the remote port here is 135, and Nmap tells us that is open. The next one here is the exit function, exit technique. You need to change this to thread, and if you don't, it's not going to work properly. Here's the password for the new user we're going to create, and you can change this if you want to. And here's the username to create. In this case, the default is Metasploit. You can change this if you want to. Now before we pull the trigger on this, and that would be simply just clicking launch here, let's go back over here to our virtual server, and I need to click inside the window just so it captures the mouse. I'm going to go to computer management, and inside computer management, this is a standalone server. It's not in a domain, so we can look at the usernames or inside of computer management. Here under local users and groups, I've clicked on users, and here are the users we have so far. Okay, and if you're skeptical, you can click on refresh here, and that's what we have right now. So now let's go back over to Metasploit. We've got our exploit picked out, we've picked out our payload, we've configured the particular information that's required for our exploit, and now we're ready to click on launch. So just click on launch. Metasploit is going to give you another little window here that tells you some things that happened. Trying target, binding to port 135 on the machine in question, bound to that. That means that the TCP three-way handshake was successful. The exploit was sent, and it says here the DCE RPC. That's the DCOM remote endpoint. That's what it means. It's got a slightly different name. Service did not reply, but it did say the exploit is completed. No session was created. Well, the payload that we specified wasn't a session. You can play around with those if you want to. That's kind of interesting. Anyway, let's go back over here to our unknown server of our virtual machine. Now, nothing's changed so far apparently, but we have to click refresh. Now, look, we have a new username, If I double click on this and open up the property sheets, if I go to member of, we have a new user, and that user has also been placed in the administrators group on this server. And this, again, I picked this one particular payload here because it's fairly straightforward and everybody understands, I hope, the implications of getting a user created on a remote machine and placed into the administrators group. And you saw how simple that was. It took actually, it didn't take nearly as long to actually do the compromise as it did to for Metasploit to show you on the screen. It's very quick. As a matter of fact, let's do this again. And this is where having a virtual machine comes in handy. At this point here, I'm going to go up here to VM on the virtual machine, down to snapshot, and I have created a snapshot here that says before exploit spring 2010. I'm going to click on that. I get a little message here saying if you restore this snapshot, the current state will be lost. Is that okay? Yes, it is. So now we're back to where we started. Metasploit is the user Metasploit is gone. So now we can run this again. Before we do, this time, let's come over here and open up Wireshark. So this time I want to capture the packets. And again, students get confused here, and I've already seen some indications even in this class that some of you are a little bit confused. You don't have to run Wireshark to do a ping sweep or a port scan or to use Metasploit. I simply want you to run Wireshark and capture the packets to see what really happened. But you don't have to get any of these things to work. And real attackers, they don't really care most of the time what's really going on in the packets unless there's a problem. And in that case, they would try to they probably run some sort of sniffer to see what's going on. This is interesting. We've got a capture menu here. We can actually click right here and pick out our interface. And it's already started up. Now, fortunately, we don't have a whole lot of traffic here, so this probably is going to be okay to leave it running like this. Okay, we'll go back over here to Metasploit. And I just closed that little window there, and I'm not going to change a thing. Everything's just the way it was. I'm just going to launch the exploit again and go back over to Wireshark and see what happens here. I may have to manipulate my interface. Interesting. Let's try that again. We can go back over here to our virtual machine. By the way, if I click on action here, just to prove to you that it really did work the second time. When you're playing around with virtual machines, sometimes you click inside the window and it takes a little while for your mouse to show up. Action, refresh. That's interesting. It didn't work that time. Wonder why not. Connection timed out. Oh, I know. Anybody else can think about why? Well, what happened when I reverted to my snapshot? My snapshot was a statically configured IP number, so I need to fix that real quick. The other machine, and I'll fix this one too. The other machines, you won't have this problem every time. Let me get back down here. I went through several options trying to figure out the best way to have you do this lab. See, my snapshot brought me back to here. And I'll just fix this while I'm here. Let's go up here and make sure settings is NAT, and it wasn't. I can close this, and I'm going to make my own another snapshot. You don't have to do this. You know what? What I'm going to do, I'm going to delete this one, and I'm going to create another one that's with the same name, just so we're consistent across all the machines, because I'm doing this on the other one. So now I'm going to take a snapshot. So this is going to be before exploit. Yeah, capitalize that. Spring 2010. And feel free to do your own snapshot and then name it whatever indicates to you it's yours. I've got 4 machines set up right now, and it won't take that long to set up a few more. We've got roughly 40 people in the class, so I don't want to have 40 people trying to use 4 different machines, although this really doesn't take that long. Alright, so now I've dealt with my little issue here of the snapshot was taking me back to someplace that wasn't quite right. So now I can go back over here and we'll rerun this again. I'm going to stop this and then start a new capture. Continue without saving. Now go back to Metasploit. And again, we're not changing anything here, and I didn't mention to you a while ago, we really, in this case, don't need to do anything to the advanced options. They're okay. So launch the exploit. Go back over here and see if anything really happens this time. And it's a little bit troubling that we're not seeing anything. Oh. Okay. I think I just had an epiphany. I think it worked that time. Let me point out one more thing to you. Click here on action. I'm pretty sure this time we have our Metasploit user. Yep, there it is. It's member of. Okay. Again, I'm going to roll this back. Snapshot. Now here's what happened. Everything worked. I was sniffing at the wrong place. So I'm going to stop this one and show you what happened. I picked this interface, which is a real interface, but what I should have done was this virtual interface right here. So now I'm going to click on that one, and now go back to Metasploit and run the thing again, and click launch. Go back to VMware and see what happened. There's your exploit, and actually it's already finished. It's that quick. I'm going to stop it right now. Now, a couple of things here. You notice that I made 2 or 3 mistakes, and I thought my way through them and fixed it. So that's what you need to do. If things don't work like you think they should, think these things through. Now, let's look at what really happened here. We've had right here, and there's there's something up here above this. Okay, here here's our ping. And that's coming from 129 to the interface, and I'm not sure why. Well, okay. I'm not sure why the virtual machine pinged its default gateway. But here's the start of the down here's where we're actually starting. And a lot of times when you're looking at these captures, you see all this stuff here. This is all NetBIOS, name service and server message block and LAN man. This is all Microsoft networking. It's very chatty. Down here's where things really happened, starting right here. If you remember, the IP number of my the IP number that my host operating system is presenting to that particular network is 192.168.7.1. It's actually coming from this machine, but it's being routed out through this number to the internal network. The destination is 192.168.17.129. Now, what business is here? Wireshark tries to map port number onto, give it a real name. In this case, my computer here is using a source port of 3107. Now, somewhere in the list, Wireshark think that's associates that with the word business, and I don't know why. Actually, I think these things right here are kind of annoying. But that's being sent to EPMAP, the endpoint mapper, which is port 135. You can see it right there, destination port 135. That's your SYN packet. Here's the reply, the SYN-ACK from the virtual machine. Here's the final ACK that completes the three-way handshake. So now we have a connection established. This packet is a DCE RPC packet, and if you look inside of here, if we come on down in here, this has a certain format that the DCE RPC service is looking for. So that's one packet. We got a reply here. Here's the another packet going from our real host to our virtual machine. And if you look on down in here, okay, let's see, the next packet is a request stub data. If you look in here, see, I'm trying to figure out which one of these packets is really the exploit. I think it's this one here. If you look in here carefully, sometimes you can actually see the word Metasploit. And it might be in the next. No, it's got to be in. It's going to be in this one, or this one, because you get down to here. This is coming back from the virtual machine, an ACK. This is these four packets here are all involved in shutting down the connection. So we're done. So I'm pretty sure that the actual exploit probably happens in this one right here, the RPC request. It might be up here in the binds. I'm pretty sure it's in, there's only like 3, 4, 1, 2, 3. It's got to be in one of those 3. Let's see how much we have in this one. There's quite a bit of information in there. Now, if you're unfamiliar with Wireshark, what you see here is this down here is the contents of the packet expressed in hex, and part of this is going to be data. That's the data. And down here in this particular section right here, Wireshark tries to express the ASCII equivalent of these hex digits. And sometimes you can actually read something out of here, and sometimes it's a gobbledygook. I was thinking I'd seen before, actually seen the word Metasploit, for the username that we created. I don't happen to see it right now. But that's what's going on. Now here's the point. We can check the time on this. Here's the first packet that's setting up the three-way handshake, and here's the final acknowledgement. So we go from 5.85 seconds to 5.92 seconds. So the actual exploit and the creation of a user and adding the user to the administrators group took less than a second across the network. Actually, it took less than a tenth of a second, excuse me. And of the packets here, we've got 11 packets, 12 packets. We had 3 that were involved in setting up the connection, 4 that were involved in closing the connection, so that leaves 5 from here down to here that were actually involved in the exploit itself. So the point I want to make here is this is very quick, and if you're using something like Metasploit, very easy. Now I pointed out a while ago that you don't have to use Metasploit. There are a lot of exploits that are, particularly when they're first developed, they're not in the right format for Metasploit. So a lot of times there's just little executables that you run. A lot of times I think you may have found this out when you did a little research on exploit code, that a lot of times they're just C or C++ code that you can compile into your own little application. So again, the point is this is very, very easy. Now, I will admit this is a very much contrived situation. We're using an older operating system here, a Server 2000. It hasn't been patched. Where's my mouse at? It hasn't been patched, but the same concept works for any operating system. If there is a vulnerability that's been discovered and an exploit has been written for it, if you haven't patched your box, it is vulnerable to that exploit across the network. Now, another thing here, there was no firewall between me and this the target. In the real world, you'd want to filter out packets going to TCP port 135 and 139 and 445, etc. You'd only want to let through what you would absolutely have to have. And another thing, if you look here, this machine is running FTP, it's running mail, it's running DNS, it's running a web server, and that may be what it needs to run. But the point I want to make to you is, if this machine doesn't need DNS running on it, you should uninstall the DNS service, because the more things you have running, and particularly the more things you have listening, the more possible avenues for an attacker to gain control of your machine. And from a security standpoint, there are times that you'd put the DNS service on the same machine as running the web service. In general, I think that would not be a good idea, because the web service is seems like there's a lot of vulnerabilities been discovered back through the years. It's much better now than it used to be, but it used to be had a lot of problems. And your DNS service is what we consider a high-value target, particularly if it's the DNS server that all your internal clients use when they surf the web. In that case, if I compromise your DNS server, I can basically have your people go wherever I want them to whenever they're surfing. Particularly if they go to www.usbank.com, I can have it go to a site that looks just like US Bank, and therefore obtain their username, their password, all kinds of interesting things I can do if I have control of your DNS server. So, but anyway, I'm rambling a little bit here. Let's review. Well, first let's go through the shutdown. Yes, there's a couple things we can talk about here. This is interesting. We should maybe have a whole different video on this. But this is ZenMap. Remember a while ago when I was talking, it was doing some more testing. So this little section right here is what's happened here. This is called enumeration. Nmap sent the proper packets to the remote machine, and it basically spurted out quite a bit of information about its NetBIOS names, which tells us this is the machine name, and I'm not sure who named it that. I don't think I did. The work group it's in, somewhere here a while ago I was noticing that it had something about the administrator's account. Quite a bit of information here that can be gleaned from what Nmap is doing for us here. Now, various places, if you read through this, some places it'll say it can't determine the operating system, and in other places it flat out says it's Microsoft Windows 2000. It's interesting to know what the operating system is, the remote operating system, because sometimes the operating system itself has vulnerabilities. Actually, that's what we had here. This vulnerability is actually in the Microsoft operating system itself. This is not another application that's been installed, or another service. This is actually part of the operating system itself. So I'll think about this, and I may have you do something else with ZenMap, because ZenMap is really cool. So for the time being, let's talk about how you would shut down your test environment here. You want to close ZenMap, and you can save this and bring it back, mail it back out to yourself if you want to, and I might have you do that again sometime. A lot of interesting information there. Now, so close that. Here on Metasploit, in this case Metasploit exists, which means we need to roll this back. So go to your snapshot, VM snapshot, go to before exploit, and roll it back, and we're good there. Now come up here to these two little yellow bars and click on suspend, so that'll have it ready to go for the next person that uses this, or you might want to come back and do it again yourself sometime. We can close that out. Now Send me these packets that are involved here. I think I'm one off. This is the first one. No, yeah, this is the first one. Mark all these packets like you've done before. The packets that are involved in the actual attack. And when you get them all marked, now I'm not to the bottom of it yet, you do a save as, marked packets, and give it a name, etc. So you know how to do that. You've done it before. Then you can close this out. Close this. This is just a browser window. Just close it. You have to. I've looked at this a time or two. I keep meaning to look and see if you can tell what you can tell here by reading this. I'm sure somewhere in here it'll actually show you where it's running, sending the compromise over. But anyway, at this point in time, I'm not really worried about this. I'm just going to close it out. And you can close this out. Now let's review. This is the host operating system that I've connected to using a remote desktop. And when I got here, I opened up VMware. And I found a suspended virtual machine called unknown server. And I need to start this up. And after you start it up, verify the snapshot. Come to snapshot and make sure that you're back down to the one that says before exploit spring 2010. That way you know where you're starting. So turn it back on. And then the next thing we did is we ran. We opened up command prompt first and typed in ipconfig /all, and we were interested here in the two virtual networks that VMware installs. So here's one of them. This is VMnet 8. Make a note of the IP range here. This is 192.168.17. This will be the 17.0 network, and this one's the 192.168.178.0 network. Make a note of those. So after we got those, and then again, this is the equivalent of footprinting. Then we come over here and opened up Nmap with the ZenMap GUI. We put in the IP range of one of our virtual networks, and we did a scan. Now, let me tell you another thing or two over here about the scan. Notice here we did an intense scan, and I think I'll maybe have you do another exercise with ZenMap here. Intense scan generates a lot of packets in a short period of time, and if anybody was watching the network under attack, they'd probably see that. So there's several more options here. You can simply do pings, you can do a quick scan, or you can do a slow comprehensive scan. The idea here is if you slow down the scan rate, maybe whoever is, if someone is monitoring the remote network, they won't see enough packets in any one time frame to realize that they're being scanned. Although I can pretty well assure you that if you have public IP numbers, you're being scanned anyway, whether you like it or not. Now hopefully your firewall is blocking most of the things that are trying to come in. But anyway, we can vary our types of scan here and our scan rate. But anyway, getting back to what we're doing, we put in a range here, we clicked on scan, and I'm not going to do this because it just takes a few moments, and I want to wait on it. But it come back and said that there's a machine alive on this IP range, and these are the open ports that are the ports that have responded as being open. So then I might as well do that. Then I took that list and started looking for ports that that are associated with services with known vulnerabilities. And that's why I settled on TCP port 135. Then I went looking for a I may not have this quite right yet. I'll check it here in a moment because I didn't get a live machine. Once I figure out the port, I'm doing good to scan right now because the machine's in suspended mode. Anyway, once I find an open port that I know that there are developed exploits for, I go get the exploit and try it against this machine. Now, in this case, I used Metasploit as a launching point for the exploit. There are for the exploit that I used, the one for the Microsoft DCOM vulnerability. There are standalone exploits that have been written for that. I just happen to use Metasploit because it makes it easier for what we're doing in class. And after I had successfully exploited the virtual Windows 2000 server by using this exploit code, and for the payload I specified I wanted to add a user and put that user in the administrators group. Then I went back and ran Wireshark to show you the packets and discovered it took less than 1/10 of a second for those packets to be sent and the deed to be done, as it were. So I want to impress upon you, basically, this is not a very hard process. If I know your IP range and I scan, I can find out the ports, the open ports that are available. Now in this case we didn't have a firewall, but in the real world, if you've got a web server, if you have a public web server, you can't put the web server behind a firewall because then nobody can get to it. It's not really public. So in the real world, you want a firewall, and you want to use the firewall to block as much as possible, but certain things still you have to let in. So that's one of the big problems. But in the real world, if this was a web server or whatever, I would do the port scan, discover the ports that were open, hopefully the operating system, the version of the web server, little things like that, and then I go looking for exploits for either the operating system itself. Well, it would have to be for the web server if you're behind a firewall, for the web for port 80, the web service itself. But and then I would try the exploit, and if you didn't have your computer patched, you would be compromised. And that's the point I want to make here. It's frighteningly easy. If your computer or your applications have a vulnerability, you haven't patched it, if it's available, if the port is accessible across the network, across the internet rather, you can be compromised and someone can basically take over your machine. It's just that easy. So again, close all this out, suspend your virtual machine, close that. Now here you want to log out, log off. This will both log you off and also close your remote desktop connection. And now you'll be back on your desktop when this closes. Now you still need to come back and close out the VPN connection. So I want you to go through this, and I've been thinking about some further questions to ask you about this whole process. Now this is one of the more important things that that we're going to do this semester. This whole idea of vulnerabilities, exploits, the importance of patching, what you can use a firewall for, what happens when if somebody discovers that one of your machines has a vulnerability that's not being shielded by, so one of your machines has a vulnerability for a port that's not being filtered by a firewall, etc. This is all, this is the important stuff that you really need to understand. So expect more questions on this, and really think about what you're doing here.